Hello, so in today's video, we're going to carry on with solving more trig equations. We're going to solve this equation here in today's video. So in yesterday's video 115 in my pure math series, we were solving equations where we took a trigonometric function, so sine, cos, or tan, of a linear expression in x. In this video here, we're looking at kind of a fake quadratic equation. So I actually did a video on this a few months ago. If you check my quadratics playlist, I did a video on solving equations that kind of look like quadratic equations but aren't quite quadratic equations. So we're going to do one of these here today. So we're going to solve this equation here where x is between 0 and pi. So let's look at this equation. So let's just start by reminding ourselves of an identity. So remember that sine squared plus cos squared is 1. So we know that that means that cos squared is going to be equal to 1 minus the sine squared. So we know that. So what you can just do with the angles in here is just change the angles and just double the angle there, which means you double the angle there. So what we can say then is cos squared of 2x is the same as 1 minus sine squared of 2x. So then we can use this fact here to actually solve the equation. So what we're just going to do is instead of this cos squared 2x, we're going to plug in 1 minus sine squared 2x. So why am I doing that instead of using double angle identities? Because again, we've got double angles here. So you may be tempted to think, okay, well, maybe we should use double angles. So the reason why I'm doing this is because I've got an equation here containing a cos, an expression with cos involved, a function of cos, and a function of sine here. I can't really solve equations where we've got different types of function going on. We've got to keep the function, we've got to make the functions in the equation consistent. So I've got to change this to a sine, so we get an equation with sine involved, or I've got to change this to a cos, so I get an equation with cos involved, but I can't really do that with the sine there. So what I'm going to do is I'm going to change this cos into a sine, so you can use this identity there to get cos squared equals 1 minus sine squared. So that's the reason why I'm doing this rather than using double angles, because then you get an equation just in terms of sine of 2x, which is what we want, because then we can get a quadratic which we can solve. So we've got this equation here. We can now expand the brackets. So we get 6 minus 6 sine squared 2x plus sine 2x minus 5 is equal to 0. I can then say that this is minus 6 sine squared 2x plus sine 2x. And then 6 minus 5 gives me plus 1 equals 0. I can then just get everything to the other side of the equal sign. So literally just change the signs of all of these numbers here. So change that to a minus sign, change that to a minus sign, and change the first to a plus sign. And what that will do is give me 6 sine squared 2x. Subtract sine 2x, take away 1, sorry, at the end there, minus 1, is equal to 0. So then now we've got kind of, again, a fake quadratic equation. So again, kind of like the video I did a few months ago in my quadratics playlist, and it's called fake quadratics. So if you see that video, this may remind you of what we would do in a question like that. So what we have to do here is we have to just pretend that this sine of 2x is basically another letter, let's say y. So then you'd have 6y squared, take away y, take away 1 equals 0. So really it's just a case of solving this quadratic equation and thinking how we could do that. So we're going to try and factorize it. And in fact, what I notice is that you've got a number 6 there. So we know that 3 times 2 is 6. So I'm just going to put a 3 sine 2x in there. And then I'm going to put a 2 sine 2x in there. Now we want factors of minus 1. So we need a 1 or a minus 1 in either one of these brackets. Which one's going to be which one's going to go where? Well, I want to try and get a negative sine 2x. So I need the negative to be, so the negative 1 to be multiplied by a bigger coefficient of sine 2x. So I need the minus 1 there and the plus 1 there. So again, minus 1 times 1 gives you minus 1, so you've got the minus 1 there. And then 2 sine x times 1 is 2 sine x. Minus 1 times 3 sine 2x is minus 3 sine 2x. Minus 3 plus 2 is minus 1, so we get this minus 1 sine 2x there. So that would be our factorization. So then now we can actually try and solve the equation. So we get kind of 2 solutions for sine 2x, or I forgot the 2x in here, sorry, my bad. 2x in that. So we get 2 solutions for this sine 2x. we get 3 sine 2x plus 1 equals 0, or we get 2 sine 2x minus 1 equals 0. Solving this first one here gives us sine 2x equals minus 1 over 3, or we get sine 2x, add 1 to both sides, divided by 2 is a half there. So we get these two solutions. So remember what our domain of x values was for the question. So x has to be between 0 and pi. So let's think about our domain then. So we know that x must be between 0 and pi. Let's just put a note of this up here. Between 0 and, pi. So that means that when you double x, so double x, that must be between 2 times 0, which is just 0 again, and 2 times pi, which is 2 pi. So what we're going to do now is take the inverse, the sine inverse of that number, sine inverse of that number, and see what we get, and see whether it does fall into the 0 to 2 pi domain of values. So 2x here is going to be equal to inverse sine of minus 1/3. Now let's do this on the calculator and let's see what we get. So just make sure my calculator in radians mode. So sine of minus 1/3 divided by 3. So we're going to get with this here minus 0.3398 to 4 decimal places. So that's what we get there. Just put a note that this is 4 decimal places. And then, okay, so what we've got to notice here is that actually that's not in our range of values, because remember our domain has to be between 0 and 2 pi. So 2x has to be between 0 and 2 pi. So actually, yeah, this inverse here that we got, this negative 0.3398, is not within our values. So I'm just going to put a cross next to that. So we need to draw the sine graph. We need to think about what a sine graph looks like between 0 and 2 pi, because our 2x inside the sine is going between 0 and 2 pi. So drawing a sine graph looks something like this between 0 and 2 pi. So there's 2 pi there, there's pi there. So yeah, again, this is sine x here. So yeah, when we did the sine inverse of negative 1/3, we got a value of minus 0.339 on the x-axis there. So negative 1/3, let's just say it's roughly there. You got this x value there of negative 0.3398. So what we need to do is go along, draw a horizontal line when y equals negative 1/3, because we've got negative 1/3 there, and we're going to get a solution there and a solution there. So actually we get two solutions here with this one less than 2 pi, because we want it to be less than 2 pi. So using the fact that, first I'm actually going to work out this second one first here, because remember a sine graph has a period of 2 pi radians. So the graph repeats itself 2 pi radians. So this point there is repeated there. So this is plus 2 pi. So this position there is going to be 2 pi plus this number there, which is just actually minus 0.3398. And then this one here, this coordinate there. So what this coordinate here represents, again, you've kind of got like a mirror line reflection there between pi and 2 pi. So the gap between this 2 pi minus 0.3398 and this pi there must be the same. So this gap must be equal to this gap because of the line of symmetry there. So this is going to be pi. So you know that the gap between 2 pi there and the gap and this number there, 2 pi minus 0.3398, that gap there is going to be 0.3398. So this gap there is also going to be 0.3398. So this x value here is going to be, I'll just try to fit this in. So this value is going to be pi and then plus 0.3398. So yeah, that would be our second solution for that particular case for the problem. So we get yeah, that solution as well. So we got to I mean, before we actually worry about solving the actual x value, let's do the same calculation with this solution there. So that was like our first case. So I just put number 1 here. And then this second case here, number 2. So sine 2x equals half. So 2x is going to be sine inverse of a half. And now we should know that sine inverse of a half is actually pi over 6, because sine of pi over 6, or sine of 30 degrees, is going to give you a half. So sine inverse of a half is pi over 6. So that is between 0 and 2 pi as required. So we can now think about our graph again. I'll try and do this in a different color, do this in pink. So half there is on the x-axis, sorry, the y-axis there. You go across there. We've got this solution there of pi over 6. And then we've got another solution there. We've got to worry about this one. And again, this is going to be pi take away pi over 6 because the gap there is pi over 6, which must be the same as this gap here, because again, the line of symmetry down there. So this number, if I try and fit it in, this number is going to be pi take away pi over 6. So 6 pi over 6 take away pi over 6 is 5 pi over 6. So we've got two solutions. So we've got this one here, I'll just put a tick by that. Or we've got 2x equals 5 pi over 6. So we've got this one, we've got this one, we've also got these two here, so equals 2x and equals 2x. So these two down here as well. So remember again, these are our 2x values rather than our x values. We can now calculate the x values just by dividing our 4 solutions by 2. So we do get 4 solutions with this problem. So we get solution 1, we get x, I'll just call them x1, x2, x3, x4. So solution 1 is going to be this pi over 6 divided by 2, because remember this is 2x. So pi over 6 divided by 2 is going to be pi over 12. Our next solution, so 2x equals 5 pi over 6. Divide that by 2, you're going to get 5 pi over 12. Our next solution, so this solution here, if you divide this by 2, so the 2 pi minus 0.3398, you can divide that by 2. And then our, sorry, I'd actually just call these all x values here. I was going to call them x1, x2, x3, x4, but I just realized I didn't do that. I just put commas there. So I may as well just put a comma with all of these here. And then your last one, pi plus 0.3398, and then divide that by 2 to get the x value. So you've got 4 solutions. These ones, this one, this one, this one, this one, and all of these solutions are between 0 and pi. So remember, x must be between 0 and pi, and that's because we specify that 2x must be between 0 and 2 pi. So these are all acceptable answers because they all fall within the domain 0 to pi. So that's an example of how you can solve this trig equation using the identity 1 minus sine squared, and then proceeding from there to get 4 solutions within this domain of values for x.